In solid-state welding, the coalescence of the part surface is achieved by pressure alone or heat and pressure. If both heat and pressure are used, the heat is not enough to melt the work surfaces. For some solid-state welding processes, the time is also a factor. No filler metal is added, and each solid-state welding process has its own way of creating a bond at the fairing surfaces. No heat effect is zone in the solid-state welding, and many of the solid-state welding processes produce a welded joints that bond the entire contact interface between the two parts rather than the distant spot or seams. Some of the solid-state welding processes can be used to bond dissimilar metals without concerns about the relative melting points, thermal expansions, and other problems that arise in the fusion welding. Forge welding is the first type of the solid-state welding processes. The welding process in which the components to be joints are going to be heated to a hot working temperature range and then forged together by hammering or similar means. Historic significance in the development of the manufacturing technology. The process dates from 1000 BC when a blacksmith welded two pieces of metal. Of minor commercial importance today, except for its variants. Second type is called welding. It's a solid-state welding process done by the applying of the high pressure between the clean contacting surfaces at room temperature. The cleaning usually done by degreasing and wire brushing immediately before the joining. No heat is applied, but a deformation raises the work temperature. At least one of the metals, or preferably both, must be very ductile. The application is for the electrical connections. The roll welding is a solid-state welding process in which the pressure sufficient to cause the coalescence is going to be applied by means of rolls, either with or without external heat. The variation of either forge welding or cold welding depending on whether the heat of the work part is going to be done prior to the process. If no external heat, it's called the cold roll welding. If the heat is supplied, it's going to be called the hot roll welding. The diffusion welding is a solid-state welding process uses the heat and the pressure, usually in a controlled atmosphere, with a sufficient time for diffusion and coalescence to occur. The temperature is usually going to be less than 50% of the melting temperature for the metal. The plastic deformation at the surface is going to be minimal, and the primary coalescence mechanism in the solid state diffusion. The limitation is the time required for the diffusion can range from seconds to hours. In the exposure welding, the process in which a rapid coalescence of the two metallic surfaces is caused by the energy of the detonated explosive. No filler metal used, no external heat applied, and no diffusion occurs. The time is going to be too short for that. The bonding is metallurgical, combined with a mechanical interlocking that results from the rapid or the wavy interface between the two metals. Only used to bond the two dissimilar metals, for example, to clad one metal on the top of the base metal over the large area. The friction welding is a process in which the coalescence is going to be achieved by the frictional heat combined with the pressure. When this process is properly carried out, no melting occurs at the fairing surfaces. No filler metal, flux, or shielding gas is normally used. It can be used to join at dissimilar metals. Widely used commercial process. amenable to the automation and the massive production. The friction stir welding is a solid-state welding process in which the rotating tool is fed along the joint line between the two workpieces, generating a friction heat and mechanically stirring the metal to form the weld seam. In ultrasonic welding, the two components are held together and the oscillatory shear stresses of the ultrasonic frequency are applied to the interface to cause the coalescence. The oscillatory motion breaks down any surface films to allow the intimate contact and strong metallurgical bonding between the surfaces. Temperature are well below the melting temperature. No filament metals, fluxes, or shielding gases used, generally limited to the lab joints on the sold materials. The weld quality is concerned with obtaining an acceptable weld joint that is strong and absence of defects. Also concerned with the method of the inspecting and testing the joints to ensure the quality. The topic within the welding quality are the residual stresses and distortion, the welding defects, and the inspection and the testing methods. The rapid heating and the cooling in localized region during the fusion welding will result in a thermal expansion and contraction that cause residual stresses. These stresses in turn cause distortion and ravage. The situation in the welding is complicated because the heating is very localized. The melting of the base metal in these regions, the location of the heating and the melting is in motion, at least at the arc welding. To minimize ravage, a welding fixtures to physically restrain the parts. The heat sink used to rapidly remove the heat. A selection of the welding conditions like the speed, the amount of the filament metal used, and extra to reduce ravage, and the preheating of the base part, the stress relief, heat treatment of the weld assembly, and the proper design of the weld bands. The welding cracks are fracture-type interruptions, either in the weld or in the base metal of the adjacent weld. Cavity defects are two defect types, similar to the defects found in the casting. First one is porosity, where small voids in the weld metal formed by the gases entrapped during the solidification. In the shrinkage voids, a cavity is formed by the shrinkage during the solidification. Solid inclusions, a non-metallic material, is entrapped in the weld metal. Most common form is a slug inclusions generated during the arc welding processes that uses flux. So instead of floating to the top of the weld pool, the globules of the slag become encased during the solidification. There are several weld profiles in the arc welding. The most desirable shape is the shape shown in the figure A. The figure B has a defect called the undercut, where a portion of the base metal melted away. In the shape C, the underfill, which is a depression in the weld below the adjacent base metal surface. And in the shape D, we got the overlap, where the weld metal spills beyond joint onto the part surface, but no fusion occurs. The visual inspection is the first type of the inspection and the testing method used in the welding process. More advanced method is the non-destructive evaluation. For example, using the ultrasonic testing, radiographic testing, the dye penetrate and the fluorescent penetrate test, and the magnetic particle testing. The third type is the destructive testing, where the test in which the weld is going to be destroyed either during the testing or to prepare the test specimen. The destructive testing can be done by using the mechanical test or the metrological tests.